Good morning, friends. In today's lecture, we have seen advantage of burners, cyclone burners like that. Now, today we have discussed oil burners. The function of oil burners: mixing oil and air in proper proportion, prepare fuel for combustion. Generally used in small capacity boiler for industrial process heating, it had to it has to prepare air oil mixture requiring minimum excess air for achieving maximum temperature. The function of oil burners: mixing of oil and air in proper proportion, prepare fuel for combustion, like that. Principle of oil firing: fuel, air. C. Mixture of fuel, air producing flame. This is principle of oil firing. Types of oil burner: vaporization burners. Oil is vaporized, gasified by heating within the burner, used in blow torch, gasoline stove, not used in boiler for steam generation. Atomizing burners. Oil is atomized by nozzle and vaporization occur in combustion phase, used in oil-fired furnace and boiler furnace. So typical oil burner. Oil is broken down into small droplets by using air and steam under pressure. So preheated oil 93 degrees Celsius to 120 degrees Celsius delivered under pressure through a tube. Steam or air supplied by annual area between oil pipe and concentrating outer tube. Mechanical burner. Oil is pressurized by a positive displacement pump. Centrifugal disperser of oil from a rotating wheel. Spray nozzle is used for oil injection under high pressure of about 25 to 35 bar. The oil leaves and the nozzle is atomized state. Rotating wheel burner oil leaves orifices as hollow cone of fine fuel particle due to centrifugal action, widely used due to less auxiliary consumption and less excess air required. The atomization of fuel can be accomplished by following method: high pressure air of steam atomizing burner, ceramical material, starting fuel, running fuel. We can see a mechanical burner, high pressure air or steam atomization burner. Elementary rotary nozzle oil burner. This is gun type mechanical oil burner. See in this diagram, we can see here schematic of gun type oil burner, air adjustment cooler, air entrance, case oil housing, electrode bracket, nozzle tube, nozzle, fan, so-called one pipe strainer, oil supply line from tank to pump, bypass around pump, pressure relief valve, cutoff valve, rotary turbulator vents, nozzle strainer, ignition electrode, nozzle, nozzle tube, electrode bracket. See here in this electric motor, we have seen gun type oil burner. See, this is gun type high pressurized oil burner. Ash handling. Next topic, ash handling. A huge quantity of ash is produced in central stations, sometimes being as much as 10 to 20% of the coal, of the total quantity of coal burned in a day. So hundred of ton of ash may be have to be handled every day in large power station, and in mechanical device become indispensable. A station using low grade fuel has to deal with large quantity of ash. Handling of ash include it removed from the furnace, loading on the conveyor and delivered to the field or dump from where it can be disposed of by sale or otherwise. So why ash handling? Handling of ash is a problem because ash coming out of the furnace is too hot, it is dusty and irritating to handle and is accompanied by some poisonous gases. Ash need to be quenched before handling due to following reason. Quenching reduces corrosion action of the ash. It reduces dust accompanying the ash. It reduces temperature of the ash. Ash form clinkers by fusing in large lump and by quenching clinker will dis- disintegrated. Clinker will disintegrated. So requirement of ash handling process, sorry, plant should have the following characteristic. It should have enough capacity to cope with the volume of ash that may be produced in station. It should be able to handle large clinker boiler refuse suit with greater personal attention of the workmen. It should be able to handle hot and wet ash effectively and with good speed. It should be possible to minimize the corrosive and abrasive action of ash and dust. Nuisance should not exist. The plant should not cost much. The operation charging should be minimum possible. The operation of the plant should be noiseless as much as possible. The plant should be able to operate effectively under all variable load conditions. In case of addition of unit, it should need minimum charges, so minimum changes in original layout of plant. The plant should have high air handling, mechanical ash handling, hot ash coming from boiler force on belt conveyor through a water set get cooled on quenching and it carries continuously by conveyor to ash bunker or dumping site. C. Remaining prior ash, steam generator, dry ash removal, stock spray, electric preparation, wet baffle, trap, centrifugal separator, facial braided fan, soot, and fly ash. So solid ash, hand ranking, gravity dump, water jet, conveying system, water sluicing, pivoted bucket conveyor, pneumatic conveyor, steam jet conveyor, ash car, wheel bagots. Conveying system discharge to hydraulic field, settling tank, dry ash pit, ash bunker. Mechanical ash handling system figure shows a mechanical ash handling system. In this system, ash cooled by water seeps on the belt conveyor and is carried out continuously to bunker. The ash is the remove of the dumping side from ash bunker with the help of truck. So advantage, disadvantage of the mechanical ash handling, low power consumption, continuous ash removal, disadvantage, suitable for coal fired, low capacity plant, maximum capacity, short lifespan, 5 to 10 years only. So hydraulic ash handling system, low velocity hydraulic ash handling system, ash follow on China where low velocity 3 to 5 meter per second. Water stream carries this ash to some capacity 15 ton per hour, distance 500 meter. High velocity hydraulic ash handling system. Upper below boiler are fitted with water nozzle. Ash follow from boiler will be carried away by high speed jet water to some capacity 120 ton per hour, distance 1 kilometer. See a boiler furnace, transition chart, submerged chain conveyor, clinker crushers, bed conveyor, bottom edge bin, dotted edge, recirculation water cool, overflow sump, recirculation water pump. Advantage of hydraulic system: high capacity, can handle mountain ash, screen and dust free. Disadvantages: due to ash and water form chemical, and due to that ash handling equipment need to corrosive resistance. Pneumatic ash handling system: boiler, crusher, ash separator, ash hopper, filter, exhaust fan. Pneumatic system can handle abrasive ash and fine dust ash from boiler falls into the crusher, where large particles are divided into small particles. A high velocity air stream created by exhauster carried all the ash and dust particle to primary separator, which work on cyclone principle. Ash is collected in hopper. The air with ripped or ash passes through the secondary ash separator and air leaving. This separator is passes through a filter for removing dust particles. So wash clean air passes to exhauster. This is cheap, occupies less space, remove all the ash and the ash handle in the dry state. Problem is that due to abrasive ash particle, wear and tear is more. Pneumatic ash handling system: high velocity air stream is directed to collect ash and dust from all discharge points. All cooled ash crushed on the way by crushers. If clinker are present, drop into airstream. Cyclone separator separate ash from air. Ash is collected in hopper for further handling for disposal by truck. Clean air is discharged from top of the secondary air, separator into atmosphere through exhauster. Typical ash handling capacity 5 to 30 ton per hour. Advantages of pneumatic ash handling system: dust-free operation, no re-handling problem, dry ash handling limited changes of ash, freezing, pinking, sticking, storage bins, flexibility in operation to suit various plant conditions. Installation cost per ton of ash handler is less than that in other systems. Disadvantage of pneumatic ash handling system: noisy operation, wearing of crusher and pipeline by abrasive ash, inflict high maintenance cost. Dust collector, fly ash pollute atmosphere, harm human, animal and plant health. So concentration of fly ash in flue gases must be brought down to below zero point 0.5 gram per meter cube before discharging into atmosphere. High ash contain an Indian core about 25% to 50%. A 200 megawatt plant using polarized core produces about 250 ton of fly ash per day. Dust collector, flue gas exhausted contain fly ash. Flue gas exhaust polarized coal fired oil contain 80% of ash content of the coal. Fly ash very fine. Most of the particle can passes through a 300 mesh 40 micron screen. Particle size varies from 1 micron to 80 micron. Basic difficulty in handling. Basic requirement of good dust collector: ability to remove very fine fresh ash particle, low capital cost, low operating and maintenance cost, good wear resistance against erosion caused by abrasive fly ash, minimum floor pace requirement, high efficiency at all load conditions. Type of dust collectors: mechanical dust collectors, dry type, gravitational or cyclone, wet type, spray type scrubbers, packed bed scrubber, impingement, impingement type separator, electrostatic precipitors. So gravitational separator work on the principle of gravity. Advantages: simple, low capital and maintenance cost. Disadvantages: cannot remove fine particles, bulky, large space requirement. cyclone dust collector, commonly used for stoker as well as pergolide firing, efficiency range 60 to 90%. We can see a cyclone dust collector. See, cyclone dust collectors advantage high efficiency for large size particle, low maintenance cost, simple, cheap and easy operation, increase in efficiency with increased load. Disadvantages: efficiency decrease with fineness of particle, high power requirement for high vortex velocity of flue gases, large space requirement, high pressure loss. Wet type mechanical dust collector. Principle: dry ash and sulfur present in outgoing flue gases is removed by water spraying, as shown in figure. To minimize corrosion problem, tank is linked with lead pipe and lined with rubber, and spray nozzle are made of vitrified materials. Advantage: high efficiency about 90%. Disadvantages: large water consumption and corrosion. Wet type mechanical dust collector. We can see wet type mechanical dust collector. Electrostatic precipitator. Working principle: smoke particles are attracted to the collector plate. Smoke particles pick up negative charges. Positive charges cooling collecting plate. Negative charges metal grade. Collecting plates are knocked to remove the smoke particle, like that. Working principle: dirty air from factory enter the electrostatic precipitors. The dirty air passes by negatively charged plate which given the position particle at negative charge. The negatively charged proton particles are attracted to the positively charged metal correction plates. Periodically, the plates are discharged and the pollution particles fall into the hoppers. Clean air is released from the electrostatic precipitator system. Electrostatic precipitator working principle condition. Electrostatic precipitators, we can see here flue gases and clean flue gases. Particles fall into hoppers. Cross section, this is cross section of electrostatic precipitators. Electrode causes particle to become negatively charged. Negatively charged particle attracted to positively charged plate. This is actual schematic diagram. This is electrostatic precipitator, actual in plan. So see here, we can cover all the first unit. We can cover here first unit all party or parameters or topics. So any doubt, any queries, all of you ask me. See here, in previous lecture, we have started in our syllabus, we have seen introduction and thermal power plant, Power generation, global scenario, present of status of power generation in India, in Maharashtra, all things we have seen in first part of first unit. After that, we are discussing thermal power plant, general layout about modern power plant with different circuits. See, after that, we have seen selection of coal, FDC, boiler, high pressure boiler, regeneration, cogeneration power plant, coal waste dust handling, all things we have discussed in this unit. After that, any doubt, any queries, please ask me. So today we have stopped here. In next lecture, we will discuss about uh, second unit. So today we have stopped here. Thank you.